Here is a review of a bunch of different ways of finding slope from a table, graph, and an equation. Let's begin. What is slope? Slope is the steepness of a line as it moves from left to right. You can see line A and line B have different slopes because they have a different steepness. Line A's steepness is less than line B's steepness. And they're both positive. If they go up from left to right, we call them positive slopes. If they go down from left to right, they're a negative slope. You have to be careful if the interval is different. For example, if this counted by 2's on one graph and by 1's on another graph, you could mislead someone into thinking that two lines were the same slope when they're not actually the same slope. So a better way, instead of just drawing a picture of a line, is to talk about slope as a number, which we're going to do in this video. First, we're going to look at a few slopes. Here in letter A, the slope is this black line. M stands for slope, and it is going up from left to right. If it goes up from left to right, we call it a positive slope. If it goes down from left to right, we call it a negative slope. If it goes straight across, that's a slope of 0. And if it goes straight up and down, that is an undefined slope. You will know it's an undefined slope if you're trying to do this in your calculator, and you're going to find that when you're figuring out the slope, you're taking any number, some number, okay, let's call it 5, and you're dividing by 0. You can't do that. But if you try it on your calculator and you actually say 5 divided by 0, it's going to say error or something like can't divide by 0, some code that's going to say you can't do it. When you get that message, remember the word for that is undefined. If I'm looking at this graph and I want to see what my slope is, I'm just trying to change colors here. There we go. I want to find 2 points where there's an intersection of lines. So for example, this is not a point of an intersection of lines. This is not a point of an intersection of lines, but this is. Do you see the difference? This one is where this line and this line cross, or where they meet. So we want to find 2 points that are like this point where I can count my rise and my run. So I'm going to keep going until I see one that's going to work for me, and it's not till I get way up here. So I'm going to go up and over to count my rise. My rise is my value that goes up or down. That's the rise. If it goes up, it's a positive number. If it goes down, it's a negative number. Over my run, that's the distance that it travels from left to right. So when I'm going from this point here to this point here, I'm traveling this way, but I'm also traveling up, okay? I want to record those two values as a rise and a run. So my rise is the distance up or down, so I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8. That's my top number. And the bottom number is the run, the distance from the left to the right. So 1, 2, 3. My slope is 8/3. I don't want to change that from an improper fraction to a mixed number. It's easier to work with slope as a fraction form. So we're just going to leave it just like that. If I did get something that could simplify, like 8/4, I would change that to its simplest form. Whole numbers are great, but we don't want mixed numbers. Let's do the same thing over here. I'm going to find a point where 2 lines cross. There's 2 of them. I want to pick the closest 2 I can, but it will work no matter which 2 you pick as long as they both land on the lines where 2 lines cross. So I'm going to count my rise, 1, that goes on top, and my run, 2, that goes on the bottom. My slope is 1/2. Here's 2 negative slopes, same thing. I'm looking for the spot where 2 lines cross. There's one spot, and here's another. I'm going to count to get from left to right, so I'm going to count from this dot here to this dot here. So I'm starting at the one on the left and moving to the one on the right, and I'm counting down 1, 2, 3, 4, 5, and over 1, 2, 3. So my rise is -5, and my run is 3. Sometimes people accidentally don't put the negative. So if I was just counting and I said 1, 2, 3, 4, 5, and I wrote 5 over 3. But then at the end, just double check. We all, I think we're pretty good at seeing that if it goes like this, it's a positive slope. If it goes like this, it's a negative slope. So I can clearly see that this is a negative slope. So I'm just double checking my answer. Yep, it needs to have a negative sign because it's going down. Let's do it again over here. Here's a point where 2 lines cross and all the way down here. Okay, I'm counting down. 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. And over 1, 2, 3, 4, 5. So I'm writing my slope as negative 8 over 5. We can find slope from a table. We're looking for the change in the y values over the change in the x values. It doesn't matter which spot you pick. We normally go through and we check all the way down if we don't know if this is a linear equation. But if you're told that there's a slope to be found, you can actually just take any point you want, look at the difference. Okay, so this difference is 6. Look at the difference on this side. This difference is 2. It's going up by 2. It's going up by 6. I'm going to take the change in my y over the change in my x. That triangle stands for change. So the right side, this side, changed by 6 over this side changed by 2. I'm going to simplify that because I know 6 divided by 2 equals 3. So my slope is 3. Let's do the next one. When I look at this one, I see that it changed by 10, and this side changed by 2. I'm going to take 10 divided by 2, and that simplifies to be 5. And on this next one, I might look at this one and say, ooh, I don't want to deal with the negative. I'm gonna start over here and say, all right, this changed by 5. This one went down by 2, so I got to make sure that I'm showing it went down by putting a negative. You could have a negative on either side, but this one shows a negative. So my change in y is negative 2. My change in x is 5. Now you might notice that on some of these, they went up by different amounts. For example, the first one, it went up by 6, and then here it went up by 3, and then here it went up by 15. But you'll notice on the left side, they went up by different amounts as well. This one went up by 1, this one went up by 5. Okay, if I checked a different spot and took the change in y as 3 over 1, you'll notice I still got that same answer, 3. Or if I take 15 over 5, 15 over 5, 15 divided by 5, well, that's also 3. So it didn't really matter which point I picked. However, I do want to emphasize that we need to make sure that we know we're dealing with a linear equation if you're only going to check one point. If you know it's, or if you're not sure if it's linear, you should check multiple points. And if they all end up with the same slope, then you know it's a linear equation or it forms a straight line. All right, sometimes our tables have values that are not x and y. So we need to decide if they are correct or not. So we want to decide if, when I say correct, is this the x's and is this the y's? Is this the x's and is this the y's? And one way to do that is to think back to our independent, dependent variables. Our independent variable was our x value. And that meant our input value. Our dependent variable is our y value, and that was our output value. So we've talked about inputs going into a function, and then we get an output back. So think about, does it make sense, or does the y value depend on what the x thing is? So for example, does the amount of hay depend on the amount of mules? Yeah, it does. That makes sense. Would the amount of mules depend on the amount of hay? That doesn't make sense. I mean, think if you're like a farmer or something who has mules and you need to feed them. would you change the amount of mules you have based on the amount of hay you have? No, you would need a certain amount of hay per mule because you would be feeding your animals. How about the other one? Distance in miles. Does that depend on how many hours you've traveled? Sure, the more time you travel, the further you're going to go. So now we can safely say that our x value is on the left and our y value is on the right for both of these. Now we just need to check how much is this changing by. This one's changing by 1. This side's changing by 2. The change in y over the change in x is my slope. When I know what these values mean, I could actually label this 1/2 bale per mule. Okay, let's look at the other side. This one's changing by 45. This side's changing by 1. So change in y over change in x simplifies to be 45. The slope is 45 what? 45 miles per hour. Miles per hour. So you can think of slope as a unit rate or rate of change as the unit rate. How much is it changing by? All right, we can also find the slope if we're just given 2 points. We're going to use this formula up here, and we're going to call each of these points a name. It doesn't matter if you name the first one x1 and y1 or the first one x2, y2. It doesn't matter. What does matter a lot is that your x value is always the first one and your y value is always the second one. You'll notice the y's are what goes on top. I always do it the same way, and I think it helps my brain to remember how to do these. So if you keep the same pattern, that will be helpful. So I'm going to call this first one y1, x1, y1, x2, y2. So now that I have them labeled, I can just go ahead and say I'm going to take my y2 minus my y1, and I'm putting that up on top. So my y2 is 4 minus my y1 is -2. And then I'm going to take my x2 on the bottom minus my x1. Now I got a little tricky math up on top. You're welcome to plug it into a calculator, but minus, remember, is the same thing as saying plus. So 4 plus 2 is 6. 3 minus 0 is 3. I can simplify that slope to be just 2. Let's do another one. x1, y1, x2, y2. All right, I've labeled them, so I'm going to take my y2, which is 1, minus my y1, which is 3, over my x2, which is 2, minus my x1, which is -5. Okay, again, I can do this problem. 1 minus 3 is -2. 2 minus -5, 2 minus a -5 is the same thing as saying 2 plus 5, which is 7. That can't simplify, so I'm going to leave it as -2/7. One more example, x1, y1, x2, y2. I'm going to take y2 minus y1 over x2 minus x1. 3 minus 5 is -2. 8 minus 2 is 6. Here is an example of where I can simplify but keep it a fraction, so I can simplify that to -1/3. All right, this one's asking me to find the slope and then graph the equation. So finding the slope, all I do is, since I know y-intercept form says y equals mx plus b, I know whatever is the coefficient to the x, whatever is in the spot where the m is my slope. Done. My slope is 1/3. Easy enough. B is something else. It's the y-intercept. It's where the line runs into the y-axis. So if I wanted to graph this, I would start here at -4 on my y-axis. Then I'm going to count this 1/3 as a rise of 1 and a run of 3. So up 1 over 3, put a dot. Up 1 over 3, put a dot. then connect those dots. Hopefully better than I did here. Here's another one. What's my slope? -3, because it's where the slope is in this formula. What's my y-intercept? +2. So I'm going to go to 2. I'm going to go a rise and a run. Now, if I don't have a fraction, I need to make a fraction so that I have a rise and I have a run. I need 2 values there. Remember, if you have a whole number, to make it a fraction, you just put that whole number on top and a 1 on the bottom. So I'm going to go down 3, 1, 2, 3, over 1, put a dot. Down 3, 1, 2, 3, over 1, put a dot. Okay, once I have three dots, I'm going to connect them with a line. Sometimes you're going to get equations that don't look like slope-intercept form. In fact, we're going to be dealing with a whole bunch of other forms soon. But what we want to do is we want to solve for y. We want it to look like y equals mx plus b so that we can decide what is the slope, what's the b. Okay, so what I'm going to do is I'm going to rearrange things so I can solve for y. So the first thing I'm going to do is I'm going to subtract x from both sides because I'm trying to keep the y alone on this side. Now, I like to keep it in this order where I have y equals mx and then the plus b. So on this side, I'm just going to keep my 15y for now. But on the other side, I'm going to make sure my negative x goes first. And then since 3 is positive, I'm going to say plus 3. See how that keeps it in x plus, it keeps it as something x plus 3 or plus b. I want to keep it so that's in that format. I do need to get rid of this 15 though, because I need y to be alone. So I'm dividing by 15. On the left-hand side, I just have y. On the right-hand side, I need to take these as 2 separate fractions. So I'm going to take it as negative x over 15 and 3 over 15. Remember that if there's no number there, it's a 1. Okay, so this is negative 1x over 15, or I can write it as negative 1/15 x. And then plus 3 over 15 would simplify to 1/5. So what is my slope? My slope is negative 1/15. Let's do it again over on this other side. I just need my pen back. Here we go. Okay, so on this one, it's a little simpler because I have everything in the same format, except there's 2 y's over here, and I can only have 1 y. So I'm going to divide by 2 so that I get just 1 y. I have y over here, y equals. Now, I can take this as 2 separate things, and I can do it without writing them out separately. I can just think of it as 4 divided by 2, which is 2x. And then plus 2 over 2, so plus, and then 2 over 2 is just 1, or 2 divided by 2 is 1. What's my slope? My slope is 2. All right, that's all for this lesson. Good luck in the chapter. Stay tuned for my next review video.